Welcome, everyone. This is Chad Stanfield with InMage Systems. I appreciate your time and attention to this broadcast that we have today. We'll give everybody just another minute to connect in. While we do that, we'll go ahead and go through a couple of housekeeping items. First of all, is questions. If questions do come up while we're going through the presentation, please use the chat feature over on the right. The moderator will collect those questions, and we'll go ahead and get those answered for you either throughout the presentation or at the Q&A portion of the presentation. If we happen to not be able to address all the questions that come up, we'll get you an email with those responses after the webinar and make sure that no question goes unanswered there. And also, if there happens to be any follow-up questions after the webinar has closed, you can get in contact with InMage at sales@inmage.com at any time. And then just as a reminder, we will be sending out a white paper following this presentation that will give us some highlights of the things that we've discussed here. Okay, we'll go ahead and get started in the presentation now. We're talking about InMage and the product offering of InMage. Just a little bit of a background is InMage was founded in 2002. It is a software-only company, and we're dedicated to data replication. That's basically all our focus is to ensure that data gets from point A to point B. We've been in production and had products deployed since 2003. We are headquartered in the United States and have offices around the world. Also, there are several patents around the technology that we're going to be discussing today, and that segment is CDP, or continuous data protection, using heterogeneous storage for disaster recovery. We like to remind everybody that a disaster is not always a catastrophic event. And in fact, the majority of the events occur within the data center and should and can be controlled. Whether it's power outage, a hardware failure, a network failure, I mean, these are some of the top items that constitute a disaster. And whether it's disaster of a full site or whether it's a single critical server, we want to make sure that InMage is there to protect you and give you the ability to bring that information back online very, very quickly. InMage has a unique value proposition. It is a network-based, block-level, asynchronous, continuous replication solution. Basically, we're using standard TCP/IP components. There's nothing special that needs to happen within your network. We do block-level replication, meaning that we're working at the storage level, looking at just the changes within the blocks themselves. Asynchronous replication, it means that there's no distance limitation. If you want to replicate to the server next door, the cabinet next door in the same data center, or you want to go around the world, it does not matter. The process and the replication is the same. And the continuous replication solution, basically it's CDP, or continuous data protection. It's always on, and it's always replicating every millisecond of change. And it also eliminates the traditional backup window because we're copying every block of change as it occurs. So there's really 5 critical recovery challenges that InMage focuses on. Whether it's disaster recovery, meaning a full site failover, meaning you have multiple systems that need to fail over into a new site, and you need to redirect traffic as quickly as possible and get that online. We have application availability with consistency points. So while we're replicating at the block level, we're monitoring the applications themselves, whether that application is a Microsoft-based application or something else such as Oracle or Exchange or SQL. We're using vendor-supplied technology to create consistency points within those applications. In the Microsoft world, we use VSS, or the Volume Shadow Copy Service. We don't care about the shadow copy portion so much as we care about the first step of VSS, which is to create a consistent state of that application. Then InMage will replicate all the blocks of change to create that consistency, and it will insert a flag or a marker immediately after that last block of change in order to maintain that known consistent state of the data. We also work with other applications outside of Microsoft for that. For instance, Oracle, we use the RMAN service. So we do have a lot of application capabilities and application integration there. We also have local continuous backup and recovery. With CDP, we eliminate that traditional backup window. We're copying every millisecond of change, and we're also copying, keeping a history of all those changes. So we have the ability to roll back in time and present the data at any point in time in the past. And we can present that data very granularly down to every millisecond. We can back up and recover for mixed environments, both virtual and physical environments. It's the same product, whether you're using physical or virtual or any combination of those within your environment. We can replicate from physical to physical, physical into virtual, virtual to virtual, and virtual back to physical. So any combination of P to V that you may have within your environment. We also support all the major virtualization vendors out there today. And so we have VMware, Citrix Zen Server, and Microsoft Hyper-V. We have WAN optimization and SLA monitoring. The WAN optimization is included in the product. It includes compression, it includes some encryption, both on flight, helps reduce the WAN utilization and the cost of the replication of your data. For the SLA and the monitoring, we have site-level reporting as well as specific volume and server-level reports. We provide a real-time RPO value, so you'll know exactly on a volume-by-volume basis or server-by-server basis how far behind your target is from your source machine. We also have some new technology. Sparse retention retains fewer application points as the data gets older. So with sparse retention, we have this means that InMage retains fewer application points as the data gets older. If you want to maintain recovered data for, say, a year, with traditional CDP copying every millisecond of change, there's a fair amount of data that gets retained in that retention log. And so it actually uses a fair amount of space. Worse than that is if you wanted to recover data that's a year old, it takes a fair amount of time to actually undo every millisecond of change to bring that information back available in a usable state. So what InMage has done is we've introduced sparse retention. And what sparse retention does is it gives you 4 tiers of customization that you have to retain this data. An example of that might be for the first week, you want to maintain every single millisecond of data, every single transactional change, and maintain that true CDP of recovering to any millisecond within that week. Then as an example, maybe the following month you only are going to maintain an hourly or a daily recover point. And then maybe for the remainder of the year, you only maintain a weekly or a monthly recover point. So ultimately, as the data gets older, you have less granular recovery points, but you have much smaller sizes from a retention standpoint and a much quicker recovery time. Also, only block changes are replicated. We keep this very optimized. We want to keep that RPO, that recovery point objective, as well as the bandwidth low. So we're only sending the deltas within the blocks. We're not even sending full block changes, nor are we sending files that need to be deduplicated and reduced in size. So we optimize that replication before it ever hits the WAN connectivity. There is no rehydration that's needed from a deduplication event. Again, we want to keep that recovery time objective as low as possible. And so by not having to rehydrate that data before it's used, we will give you that ability to recover very, very quickly and present that data in a usable fashion. And again, we do have application-specific recovery and protection. Whether that application is Exchange or SQL or Oracle or SharePoint or even MySQL, regardless of the operating system platform that it runs on, InMage supports all the major open systems platforms from Windows to Linux to Unix to HPUX and AIX. We can provide granular level of protection for all those platforms and many of the applications that you'll find in an enterprise today. The ultimate goal is to reduce and minimize that downtime and data loss. We want to maintain that very low RPO and very low RTO while still providing you with a TCP/IP standard-based replication solution. In addition to just the backup and recovery that we've talked about, the actual backup part is actually pretty easy for InMage to do, and we've done that for a while. We've always maintained application consistency. We've always provided continuous data protection. And recovery has always been easier and much simpler than with traditional backups. In addition to that, we've added some new capabilities here to simplify the object-level recovery, whether that object-level recovery is with an Exchange or whether it's a database or whether it's just a file that we're bringing it up. So the additional modules that include object-level recovery, for example, with Exchange, the recovery manager for Exchange, we offer customers the ability to recover Exchange at the mail or the mailbox level. allowing you to recover more granularly and with greater ease. Basically, you can present any user's mail store at any point in time, and you can present it very, very quickly. Then you have search capabilities to be able to discover any message that you might want. And then you also have the ability to either extract that message into a file format such as HTML that's globally readable or an EML format. You can also push that email back into the active mail store of that particular user. So not only do we give you the ability to present that mailbox very easily, but you can also recover that information and view that information easily as well. This is something that we'll go through today in our lab. In addition to that, I just want to clarify, we do have full site level exchange, failover capabilities and protection as well. This is simply in addition to that overarching goal, is that object level recovery. When we're dealing with databases and file servers, we have the ability to quickly present virtual snapshots of the data, whether it's at the volume that's hosting a database or a volume with a file server. It's essentially the same process. We allow you to retrieve files and data objects at any point in time in the past, and we can also do this virtual presentation using 0 additional disk space. So you can present that volume, validate that volume, use it in a read-write mode. You do not break replication, and you do not have to use any additional disk space to do that. We'll go over a couple of high-level lab examples here of what an environment might look like. In this environment here, this is essentially a non-VMware environment where we have multiple physical servers replicating into physical servers. Some of them are going physical into physical, and some are going into a virtual environment. InMage is a host offload solution, meaning that there is a data tap that resides on the server that monitors the write I/O. It offloads all the processing to a second tier of architecture called the process server, and all the information is being replicated through that process server and protected on a remote site. Whether that remote target is remote in a secondary site or whether it's a local target, it does not matter. InMage also offers the capability of consolidation. We can go many-to-one and one-to-many in our replication. It is truly a one-to-N solution. We offer the capability of offloading to tape, so you can present the volumes virtually and still allow tape offloading. Also, we do have caching and queuing capabilities that are managed on that process server. In the event that there was a WAN outage or the event that you had to do some client maintenance, reboot the server, essentially you do not break replication. The process server will continue to cache and queue the changes as they occur. Once that the server comes back online or the WAN connectivity is repaired, then it simply continues to push down those differential changes into the target machine. So you can present that data very easily and very quickly. The most important part of that caching and queuing is it is not done on the production server. There is 0 additional overhead to your production server while doing that. And also there's no blackout windows, meaning if you had an outage yesterday, for a few hours, and then everything caught up overnight, and today you had a request to recover data from yesterday, you'd still be able to do that because of that caching and queuing capability. We move into a VMware-specific environment. Because of the API capabilities and InMage's relationship with VMware, we do have some specific tools that tie into VMware. We basically allow for virtual to virtual and P2V migrations real time, using the InMage technology. The first thing that we see is on the remote site, the target site in the lower right-hand corner is a vContinuum target. We often refer to that as a master target server that collects all the change information from the environment that you're protecting. The first step would be to select the servers that you want to protect, whether they're physical or already virtualized within the vSphere environment. And essentially, we would take a copy of the metadata of those servers, and we would build a ghost copy of those servers on the remote site. Those servers would be powered down, and then we would deploy and associate the appropriate amount of storage to that vContinuum target to protect all of the servers that have been selected for protection. At this point, traditional CDP replication will occur, going from many to one, consolidating down to that vContinuum target onto the appropriate disk store that's available there. At this level is where you would manage all the replication on a day-by-day basis. As we go ahead and recover, you basically select one or more servers that you'd like to recover. You tell it at what point in time you want to recover that data. It'll roll it back to the appropriate time specified. It'll detach the storage from the target, attach it to the virtual machine you've selected to power on, and it'll bring that online. We do offer the capability to make metadata changes as well to that process. So we do have a question about other virtualization technologies outside of the three that were mentioned, which is Microsoft Hypervisor, Citrix Xen Server, and VMware. The other virtualization solutions out there, we certainly work with them. There is no integration into the hypervisor level. So an example might be Oracle VM or VirtualBox or KVM on the Linux side. We would basically protect the guest machines the same way that we would protect a physical machine. So we can certainly work within those virtualization environments, but there is no integration at the hypervisor level. We'll go ahead and continue the presentation. At this point, I would like to go into a lab environment. We kind of show you through a little bit of the interface that we have, the simplified RPO and RTO, so we can view, the minute-by-minute tracking that's there. We'll do a virtual snapshot recovery as well as an object-level restore. Okay, here we are in the lab environment. The first thing that you would see as you log into the management interface of InMage is the actual high-level dashboard. So the high-level dashboard is essentially what's going to show you what's going on within your environment. Underneath the health plans here, you can see we have several servers or groups of servers that are being protected, whether it's Exchange or Oracle or P2V that we just talked about from an InMage perspective. We've got a MySQL as well as a Microsoft SQL server here, as well as some other demo servers in this lab. We can very quickly see that everything is in a healthy state. We'll go ahead and select one of these plans here. I'm going to minimize the menu on the left just from a screen real estate perspective so we can see what's happening here. Within this Exchange server, we notice that the E volume is actually up and presented, and we can see the real-time RPO of that specific volume here. We're just over a minute behind in that replication. What that means is that if we were to have an outage right now at this moment, we would lose about 1 minute's worth of data. And so when we present that volume, basically our data loss is about a minute. We also have some jobs that are running continuously to ensure the accuracy of the data that's being replicated. We also are taking configuration changes of the metadata information about the environment. So the metadata information would be, new mail databases that have been added or removed, and we're basically monitoring that every 6 hours. That's a variable that you can set to whatever your desires are. We're taking readiness checks. So we're monitoring the server itself for dependencies to ensure that everything is good, not only on the source machine as well as the target machine. And lastly, we're taking those consistency points that I talked about. In this lab, they're scheduled for every 30 minutes. That time variable can change as well based on what your needs are. So you can set that up. If we were going to recover some data, basically we can go into the Recovery tab. We're going to do a consolidated lab demo today because of the time that we have allotted here. In the recovery, I'm going to choose the Advanced menu so we can walk through a couple of the steps that are there. And I'm going to create a recovery snapshot. In the Advanced menu, it basically shows me all the servers that are being protected. And I can simply select one or more servers that I want to bring online. We're going to go ahead and bring Exchange because ultimately I want to do a message level restore. I'll go ahead and select the recovery option. I'm going to hide the menu again on the left just so we have more screen real estate. Here in the Advanced menu, I'm given, do I want to go to a specific time or do I want to use an application consistency point? Because of Exchange, we do need to use an application consistency point. So I'm going to go ahead and select that. The next thing it does is it provides me with some filtering options so I can narrow in on a consistency point that I may want. In addition to that, it provides me with the list of the most accurate or most recent consistency points that are available. So essentially, I can just go in and I can select any one of these consistency points here. I'll just select the last known good one. The next thing it asks me is, do I want to use physical storage to present this data, or do I want to use virtual storage? I do not have any additional white disk space available, so I'm going to virtually present this data. When I virtually present the data, that means I'm going to use 0 additional disk space to present this data. If you do need read-write mode capabilities, which I do need in an application recovery such as Exchange, I simply provide it with a location where I can temporarily put that write information. So it'll redirect any writes to that temp location that you've provided there. Next, you're provided with all of the drive letters that are available on that target server where the replication is going to. Simply select one of the drive letters and choose Next. Here it's going to validate what you're intending to do. Basically, we're intending to work with the Exchange target server. We're going to work with the E-volume, and on the Exchange target server, we're going to present the E-volume as the Z-volume. And we're going to use this tag that was taken at this point in time, and we're going to do it virtually. So I'm going to go ahead and select Finish here so it can go through that process. In the meantime, I'm going to open up a desktop session into that remote Exchange server. So I'm now on my remote Exchange target server. You can see that we just have our normal Windows interface here. Essentially what's happening right now is I've selected to roll back to the last known good consistency point. So it's working with the E-volume, which is under protection, and you notice that we hide it from the user interface to avoid any accidental usage or accidental corruption of that data. It is connected at the kernel level. It's still going to be receiving block level changes as we go through this process. But essentially what it's doing is it's looking at that E drive as it looks right now, and it's going to read that retention log that we have, and it's going to undo every piece of change between now and whenever that last known good consistency point was. But ultimately it's going to go and undo every block of change that occurs, and it'll present this drive as the Z drive letter on this interface. And so it takes about a minute and a half to go through this process, but that drive will be presented as Z, and it'll go through the appropriate plug-and-play process for Microsoft Windows. There it is now. Here's our Z volume. If this were just a regular file volume, we could navigate into this file volume, and we could actually go and recover any of these logs or view these logs or anything that might be there, and we could literally just copy these back into production. Because it's Exchange, we do need to work with an Exchange application in order to read this information. The same thing as if it were SQL data or Oracle data. We would simply use the appropriate application to read that information. We're going to do a message level recovery. So I'm going to launch the mail recovery process here. Basically, the first thing that we do is we select the mail store that we want to recover. So I'll go ahead and provide it. We want to do an offline recovery because we do not have Exchange running on this server. And I'll basically provide it with the path with the database itself, and then also with the path to the log files. Remember, we presented them on the Z drive, so I'm just going to select the Z drive, and I'll grab the mailbox database here. And again, for the system folder, we're using the one that has been presented on the Z drive, and we'll go ahead and select OK, and we'll hit Finish. Basically, once everything is processed, we'll go ahead and we'll be able to see the users that are available for recovery. So we have just a small set of users on this test environment. We can expand any one of these users, and we can actually see their mailbox here. You can go into the mailbox, and we'd be able to open any one of these messages. It'll simply launch Outlook here, and we'll be able to read the message no problem. So we can see that is the message that we would like to recover. Simply close that. If I do want to recover it, I can right-click. I have my option to export this into several formats that are available. If I simply want to export it but not recover it. If I want to restore that message, I simply select the Restore option. I can use the default profile. This has to do with permissions. If you do have permissions that need to be set explicitly, you do allow for that as well. So I hit Restore. And essentially what comes up is our list of users that we want to restore it to. Well, we know that it was the Demo 2 user, so I'm simply going to choose that user. I could also restore it to other users as well if that was an appropriate action to do. And I'll go ahead and hit OK here. What that did is it actually took the message that we have and it pushed it into the active mail store for that user Demo 2. So if I go into Outlook, which is actually up and running because we launched it to view that message, what you'll see is within the inbox itself, we create a subfolder called InMage Restores. When we go into that subfolder, you'll see that here's the message under today that has been restored. And so we could go into that message and validate that indeed that message has been put into that restored subfolder within the inbox. That's basically basically what the file restore looks like, the message level restore that is available for InMage. Again, this was an abbreviated demonstration to fit within the time frame that we have, and I do appreciate everybody's attendance here. Again, thank you for your time today. If there's any additional questions beyond today, you can reach us at sales@inmage.com at any time, and you can also reach this number, which is 1-800-646-3617. Thanks again.